Here are a few examples of tooling that we use to make carbon parts. So this is, for example, the pattern, the positive mold for the dashboard of the C2 that we saw being designed in the tool development. And so this is a positive, that's not the actual tool. Out of this, we make the carbon fiber negative because it's a big and complex part. Sometimes we make a direct mold, like for example here, this is the mold for the C2 mirror. And that's a multiple piece part because you have undercuts, so you wouldn't be able to take the part out after curing if the mold was not disassemblable. So when you have a part like this, when you have a mold like this, the part is made directly in the mold, like for example this part. But for more complex shapes, we usually have this step in between where you first have to make a positive and then a carbon fiber tool. And this is actually great because the tool has the exact same expansion rate like the part, because carbon fiber and aluminum in the oven, in the autoclave, when it gets hot, they don't expand exactly the same. So you have to calculate in how much it deforms during the curing. So when you have a carbon fiber mold, you don't have that problem. So let's see how we make parts based on these tools. This is where we laminate all the parts, and we use a bunch of different materials here. So let's take the simplest one. This is raw carbon fiber. So this doesn't have any resin inside, it's dry. This is pre-preg carbon fiber, which means it's pre-impregnated with resin. So we have to keep those in big fridges because the resin starts to react on temperature. And we have a bunch of different pre-preg materials that are bigger like these, bigger weaves or smaller weaves, depending on the application and what you want to do with that part. But also different other materials, like for example Kevlar or glass fiber for electrical insulation and copper for EMC shielding. So for example, what you need to do in some cases, for the exterior parts of the car, for example, you use exclusively carbon fiber only. But for some components, like let's say a PDU housing, power distribution housing, which is an electrical component, you need to have electrical insulation. So you cannot use carbon fiber because it's conducting electricity. So you use glass fiber sheets with copper laminated into them for electromagnetic shielding. And then sometimes you want to use Kevlar for penetration protection if, for example, you have some kind of crash or you pick up a part from the road and it can penetrate in the battery pack. That's why we use a different mix of materials, and it's very important how these materials are laid. So we make here the obvious components, which are like the doors or the bonnets or the interior parts, but also some technical components like battery pack housings or module housings or power distribution housings and so on. So it basically starts with a roll of material. It starts with the roll of carbon fiber or glass fiber or whatever you use for that component. The machine is cutting those rolls and the laminators get the cuts and then laminate them in the order that they get from the ply books. So we have the ply books which says which part or which material has to be laminated when, in which order, in which direction. And this is really important to follow this because, for example, sometimes we use unidirectional carbon fiber, which means it can pick up force only in one direction. So if you have a wrong angle, if you have a misalignment there, then the part is not structurally sound because it cannot pick up the loads for what it was designed for. After lamination, the parts are vacuum bagged. For example, here, these parts are put in a vacuum bag. So it's important to suck all the air out from here because in the autoclave, it's all being pressurized. So to have a fitting of the carbon fiber plies to the tools. So after this station, they go into the autoclaves. And then there we put them under immense pressure and temperatures to cook them basically and make the resin react so that the carbon fiber plies from a soft textile-like material become harder than steel but lighter than steel. After this process, they get put out of the mold, get trimmed, cut, bonded, if necessary, upholstered or